Start the recording. Good. Okay. And then, okay. So to start off today, I want to talk about disambiguate two terms you've probably heard me use a bunch, but I haven't actually defined yet. So you might have heard me use the term website and the term web API. So I've probably used these somewhat interchangeably if you've sort of noticed me use those terms, but they do have an important difference. So they're both tend to be things that are server hosted that one can access by making HTTP requests. So that HTTP client makes that request to that HTTP server and gets back a response. But kind of beyond that, they have some key differences. Websites are typically meant for human consumption. They'll return HTML back to you. So a great example, like this application here, docs.google.com, this is sort of like a website. Or sometimes you'll hear me use the term like web application is kind of maybe the more newfangled term there. But this is something where it's meant for humans to look at. On the other side, you have web APIs. So web APIs, they are meant for machines to communicate back and forth. So it still uses HTTP, they still use all the stuff we've talked about, but typically you'll see web APIs transact in something like Json, or there's some other formats too, but some sort of protocol that's machine readable and easily understood. For some examples of that, so any of the queries and code endpoints we've been using, those are examples of APIs. The ones we talked about yesterday, those were communicating with JSON. So those kind of strictly nicely fit that box. But just everything we've been using up to date, I would consider web API as well. Like they're not really, they're giving you back just plain text. It's not really meant for like a human to look at that and read it. It's meant for like a machine to process it. If you wanted a human to read it, you'd probably send back some HTML and nicely style it so a user could go to that in a web browser and make it work. But we didn't do that. And we're going to use a few other APIs today. We're going to talk about a few other APIs today. The New York Times API, I've covered that a few times. So this is sort of a system where the New York Times provides a server, and we can make requests to that server and get back data in JSON. So that's an API. It's used for machines to get information about the New York Times. We're going to use the GitHub API later today. That's another example. So there's a bunch of different API services out there. I just want to make sure it's clear sort of the difference. Really the reason why I want to make it clear there's a difference is because today we're going to be talking pretty much exclusively about web APIs. So websites, all the sort of HTML stuff and returning HTML from a server, that's important, but just not the topic for today. Okay, so actually before I get into that, any questions about this web API, website sort of distinction? Okay, cool. So if we're going to be talking about web APIs, I should probably actually define that term API. You may or may not have come across it. So API stands for Application Programming Interface. It tends to be a set of functions that you can use from one system to access another system. And also, it's worth noting that like web APIs tend to work over HTTP. That's sort of like the way you do that communication, the way you say, hey, other system, do this thing I want you to do. But it doesn't have to. There are a bunch of different systems that don't use HTTP as an API, as like a transport for an API. A great example with you've probably talked about well, actually, no, actually, maybe you haven't yet. Have you folks talked about Node yet at all, or is that? I'm sorry, I'm getting things out of order. Okay.
Yeah, a
Um.
little bit in the beginning.
Okay. Um. So maybe an example of like an API that is not HTTP based is you might have like some JavaScript code you bring into your website, like an extra script tag you include. And that includes a bunch of functions that it defines globally in the web browser sort of browser context. And you can call those functions from your custom JavaScript to do whatever you want. And in that case, that's an API. You have some sort of other thing, other module, and your code's calling that module, calling into it, giving it sort of commands, and then other modules doing them and giving you sort of like status responses, like, yeah, okay, that worked. Or maybe like your API is dealing with math and like doing math operations. You have like an add function. So you make that API call to add two numbers. It gives you back a response with the result. So we're going to be talking about APIs in the context of HTTP today, but like that's not sort of strict. Like you can have APIs that just work generally as well with other transport mechanisms. Okay, so web APIs are kind of interesting because using HTTP as a transport for API sort of uses was not really HTTP's like original use case. HTTP, Hypertext Transfer Protocol, its original goal was to allow humans to access documents published on the internet. So the whole idea was that like the content types of things you get back from a server would tend to be things like HTML or like PDFs or something more in that direction. So it would be like a human would go to a URL and get stuff back. But what ended up happening is, as sort of the web evolved, people started building these more complicated web applications that needed to do more complicated things, access third-party resources. And as we talked about before, the only language that the web browser speaks is HTTP. Externally, I guess, so like to other systems. So if you want to, with a web browser, access another system and get data, the only way you can do that, the only language you can use is HTTP. So therefore, people started exposing their API systems over HTTP as the sort of work around that limitation. And as sort of people went through that, they sort of like started exposing their API endpoints over HTTP. They started realizing that certain techniques worked better than others. So you can maybe think here, like, let's say the sort of most straightforward thing. You have like a function, and you want to make a request to a server with parameters to that function. And when you make that request, the server runs the function with the parameters you give it, and the result from the function gets sent back to the client. So that example I used before, like you have like an API endpoint that's like post/add, and maybe it takes two parameters, two numbers, and you send that request off, and then the response, you get back the two numbers summed together. So you could do that, and that's actually where a lot of people sort of started. But that has kind of some problems. Like it's a bit difficult to maintain. Kind of thinking back to some of the stuff we talked about at the beginning of the Json lesson yesterday. If you need to evolve that, like you need to add parameters to your add function, that becomes kind of difficult to scale as an approach. So with time, people came up with a lot of different techniques for organizing their API endpoints, for thinking about how this information will be laid out. So things like, what methods do you use? Just get and post? You use other methods? How do you structure your paths? Like if you need to get like a list of users, do you make a request to /user, /users, plural, /user list? And there's probably like a million other possible permutations there. And then also things like, what kind of data type do you send back in the body? JSON, something else? So we're going to talk about, or I guess we're going to discuss probably what is the most widespread set of conventions for laying out API endpoints in a web API. Now, I should say this isn't the newest approach. It's not the fancy new thing, but it's one of those things where it's been around probably for, say, like 15 years. And it's the kind of thing where everyone looks at it and they have sort of their complaints with it. They're like, oh, I don't like how this works, so I wish this could work better. And there tends to be this cycle where they see things and they're like, oh, I can make it better. And they change it. They sort of make their own thing and realize, actually, that has some problems that going back to what we're going to talk about, like, doesn't have those problems. So it ends up being this weird thing where there's a lot of sort of experimental stuff around, but a couple different standards have sort of emerged that have had some staying power. So we're going to cover REST, which is sort of the one of those standards that's had the most staying power. So REST is an acronym that stands for Representational State Transfer. And as I kind of said before, it's sort of a number of rules that help define best practices when organizing and thinking about web APIs. The reason why it's representational state transfer, it defines how state, the data being sent between the two systems, is represented and transferred between them. So that's kind of breaking down that acronym a little bit, what that means. Okay, so I used a term here, best practices. One of the reasons why I think REST has had some staying power is because it's not a technique that locks you into how things work. It's sort of like a set of guiding principles of like guidelines. So what that means is if you have a unique situation and you want to be like, I need to break the rules to make that happen, like that's kind of totally fine and something people tend to do a lot of. But on the other hand, if you don't have like any, like if what you're trying to do fits the rules of REST, and a lot of things do, then you can follow those rules. And because you follow those rules, like there's a level of predictability. Whenever someone interfaces with the REST API, they kind of know roughly how it's going to go. They know kind of roughly how the endpoints will be laid out, how those methods will be used, what kind of data types will be used, things like that. So that sort of like non-strict nature, I think, is a real advantage to REST. Okay. Any questions before I keep moving here? Okay. So we're going to cover a couple really important concepts in REST. And the first one is what's called a resource. So in REST, a resource is like a noun you perform actions on. So my example here I have on the slide is, imagine you have like a car dealership and you need to sort of like make some sort of web API system so that you can interface with all the different things that would happen at a car dealership. So think about like common things that would happen. You might have like cars that are on the lot. You might have like customers that come in the door that you need to sort of track information about them. You have like salespeople that are selling the cars. You have like inspection certificates on the cars. So they're sort of like, these are all entities in the system, all things that are important to track. And in REST, those things are called resources. Importantly, resources aren't always nouns. Sometimes people will be a little creative and try to like nounify like verbs and stuff like that to try to make it fit into this pattern, but like it tends to be nouns. So like car, customer, salesperson, like inspection certificate, those are all different nouns. So on every resource in REST, there are sort of 4 core operations that tend to be commonly implemented. You don't have to always implement all of them, but these provide a pattern you can follow when you do need to implement these. And these operations fall into a pattern called CRUD. So CRUD stands for create, read, update, and delete. So you can think of these sort of as like the actions you would do in a REST context. So you can pair any one of these CRUD words with one of your resources. So for example, like create a new car, or like update a car, or like update a customer. Maybe a customer sort of like has had a transaction. You want to log information about that on the customer. Or let's say you fire a salesperson, you could delete them from the system. So there's like, this is what's kind of cool, where like these create, read, update, and delete actions, if you think through most problems, they map pretty well to like most things you would tend to want to do on data in a system. Okay, any questions about resources or CRUD? Okay. So here's how this actually tends to go down. Whenever you have, so I guess I should say to start with, resource names are sort of mapped directly to a path. So just like we talked about way back when we were talking about HTTP as a protocol and how that works, the path sort of defines like what you're getting, and the method defines like the action you're performing. So these sort of like resource and CRUD concepts map kind of directly to those. So if you wanted to, let's say we have a cars resource and you wanted to create that cars resource, what you could do is make a post request to /cars. So post as a method maps directly to create as an action in CRUD. So you'll see there's this kind of like a direct mapping from method to CRUD action. Let's say you wanted to read cars. So read could be one of two things. It could either be give me a list of all the cars or give me information about one particular car. They're kind of two different flavors of the same operation. So if you wanted to just get a list of all the cars, the way you do that with REST is you make get to /resource. So get /cars. If you wanted to get one of your cars and all your cars have some sort of unique identifier on them, what you would tend to do is something like get /cars/ the unique identifier. So this is also touching on another pattern we're going to see here in REST, where when you have a path, you tend to the path either tends to be /resource name or /resource name /ID. And what that means, either you're targeting the whole collection or you're targeting one item within the collection with sort of the operation you're performing. For update, when you do an update, the method you want to use is the put. You sometimes also use patch. We're not going to talk about that today, but I just want to say pedantically, like patch sometimes you'll use here, but you tend to use put. And because you're updating a single item in your resource, single entry in your resource, you would make a put to /resource /ID, so /cars/ID. And then delete, same kind of thing. So delete just directly maps to the method delete, and you go delete cars ID. We're going to sort of repeat this over and over. This sort of pattern is probably going to, I would expect, would become second nature to you, especially over the next few weeks. This is going to be a thing that's going to keep coming up, these sort of like REST patterns. Real quick, I do want to also say that I want you to notice that this is cars plural and not car singular. In REST, by convention, you always make resource names plural. People don't always follow that rule, but like that's what you're supposed to do. And the reason why that is because if you make them plural, they kind of read in English a little bit nicer. So in this case, like post cars is like, you can think of that in your head if you just substitute post for create. It's like create some, like add something to like the list of cars. And then read, like get, so like list all the cars. And kind of so on and so forth. So it's just like that plural sort of pattern is what tends to get used. Also, importantly, we haven't really talked much outside of the post and get methods so far. This is sort of the first place where we're going to start to see a bit more widespread use of methods. So in REST, you tend to use get, put, post, and delete, or I guess in their CRUD order, post is create, get is read, put is update, and delete is delete. Okay, we're going to walk through each of these just to show an example. But before I do that, any questions?
Yeah, I got a question.
Yeah.
So I see the identifiers are in like the carets. Do you have to put the identifier in the caret after that slash?
Yeah, so good question. I put this in the carets just because this is, I guess, just the common like syntax to specify like a parameter you substitute in. In practice, it would actually look like this.
Oh, okay.
Yeah, good question. Sorry about that. Okay. So here's an example of a create. So I'm making a post to /cars. I'm specifying my content type and accept header properly. And then in my body, I'm specifying some JSON. So also worth saying, REST tends to use exclusively JSON. That's kind of the language you're using in the body to communicate. So when you make a post, you tend to have an object in your body. And that object has a bunch of keys and values that all map to sort of like one single, like one conceptual entity of your resource. So in this case, our car resource here has two fields in it, company and model name. And so think of this sort of like as a table. You have like two columns, like company and model name. Company is Pontiac, model name is Vibe. So I make this request, and then back from the server, what you should get if the server is following the strict REST principles is you get back a response with a status code of 201 created. So it starts with the 2, so everything went well. 201 created is just means that like the server made something, it created a new entity for you. Sometimes you get back a 200, sometimes you get back other things, but you should usually get back a 201. And then in response, you'll get back in the response body this representation of that car. Now that should, if everything worked as you expect, kind of match pretty closely what's in the request body. But importantly, there's this ID field that's in this. Now, this won't always be called ID. It has a few different systems do it differently, but it's very common. I would actually say like this pretty much always happens. You'll get back some sort of ID field or some sort of identifier. The reason why this is important is because this field is now acts as sort of like your reference you can use whenever you want to touch that row again. This ID could be a string, it could be a number, it could be a bunch of it could be whatever. But importantly, like when if you want to later on affect this row in some way, like update it, delete it, do something else, you're going to want to keep this ID around somewhere. And there's a way you can get it again. So it's not like after you create it, it's like lost forever or something like that, usually. But this ID is like, if you don't keep that around, and let's say you wanted to update this car, you don't have a way, like you don't know how to, you don't have anything to stick there to do the update. Okay, so that's what a create roughly tends to look like. Here's what a read tends to look like. So I'm making a get the slash cars. I've got my accept header, so I'm getting back JSON, that's what I'd like. And the server will send back usually a response with 200 OK. And you'll get back something that looks kind of like this. This should look kind of familiar to some of the JSON structures we were talking about yesterday. We've got an array of objects here. And you tend to get back, in this sort of case, an array of objects, one object per like row in this like metaphorical table that's being represented here. So if I made this request, this read request, right now, and I might get back like an empty array. So just like open bracket, close brackets. Then maybe I make this create request. So I make a post to slash cars. I include this data in there, and I get back my 201 created with all this stuff here. And then let's say I make this request again. So read, create, and now I'm doing a read again. This other read, I'm going to get back something that looks a lot like this. So I'm going to get back, instead of an empty array, I'm going to get back an array that contains the item I created in the previous request. So really here, like the data that's being represented back in the response is all based on some sort of common representation on the server that's shared between requests. It tends to get stored in a database, but you'll get to that in probably like a month or two. Okay. Update. So if I want to make a change to a car, what I'd do is I'd make a put, the slash cars, and then this is where that ID comes in. So I'd stick that ID there, specify my content type and accept header properly, and then in the body include a new object representation, just like the object representation when I was doing the create, that now has whatever changes I want to have in it. So before I had company Pontiac model name Vibe, now I have company Ford model name Vibe. And now in my response, you'll see that company here is now Ford, no longer Pontiac. Importantly, though, this ID and this ID are the same. They should, like, once the ID gets created initially, it should never change. It's what's called immutable. It's like locked in time. And the reason why that's important is because if you could change it, then all of a sudden you could make it so that like you could change something's ID, like you could switch IDs or something like that. And if you have this ID saved somewhere, all of a sudden it might not actually point anymore to the thing you think it might point to. And that leads to some very confusing issues. In certain systems, you don't have IDs, and this becomes a real pain to deal with. Cool. So that's roughly what an update tends to look like. And then a delete, really simple. So a delete, if you want to remove an item from a resource, you make a request to /resource/ID with a delete request or delete method. And then in response, you tend to get back a 204. You can get back a 202. You're gonna get back some kind of 200 if things are successful, but 204 is what you probably should get back. So 204, no content, is a response you can send when you want to send back like success, but like no data in the body. It sort of like tells the client, I'm going to omit any body data. It's just like, it worked, that's it. Of course, if any of these endpoints could return other status codes, 400s, 500s, and at that point, we're sort of back to what we talked about earlier in previous weeks, where those status codes, it might be you screwed up in the request you made. It might be that the server wasn't able to do your action as you requested it. So I'm sort of going through the happy paths here, the success cases, but know that it's possible for there to be failure cases too. Okay. Any questions on create, read, update, delete, how these requests tend to look? We have a couple of different practice exercises, so we're going to go through it, but I want to open the floor first.
Yes.
Yeah,
I noticed that in create and update, there's the MIME type of content type, but not in delete and read. Is that because you're adding a body?
correct. So there's no request body in delete. There's no request body in read.
Okay. Thank you.
Yep. I do want to call out that read, I have an accept header here, and it's because the response is coming back as JSON. So I guess maybe to be pedantic, really what this should be is something like that.
So the request is going to have the content type.
So
I mean, not the request, the response is going to have the content type.
content type is a header that can be included either in the request or the response.
Okay.
Often both. So what content type says is it's the type of the data in that part's corresponding body. So
Oh,
if you have a get or if you have like a post request, this content type here is referring to this.
okay.
And yeah, I should put these there. And then this is referring to what the data it wants to get back in the response. And then this refers directly to this. So most of the time, these are going to line up. It's not guaranteed, but most of the time it will. It's sort of like I'm asking for something and I'd like to get that. And usually I'll get it, but I might not get it. Cool. Any other questions? Okay. So I kind of touched on this before, but I want to say it again because it's an important point. The reason why REST and other patterns like this exist is because they allow you to follow patterns that other people know how they work. So you can make APIs that are predictable. So with what I've just said through like all these different slides here about like all these different operations, if I told you, okay, I have an API endpoint hosted on this server here, or I guess rather, I have an API hosted on this server here, and I have a resource on that server called like users. And I told you to create a user, like that's all I have to tell you. You can just, you sort of at that point can just go from there and be like, okay, if it's a REST API, I know it follows all those conventions, then it'd be a post/users. I'd include my user metadata in the body. and you get back a 201. So it's kind of nice because you don't have to explicitly spell out all that. And it means that you can kind of make some assumptions in how you work with a system that are going to generally be correct. Okay, so importantly, though, I mentioned before how REST is flexible. So the rules are just laid out. They're great and all, but sometimes you want to do things that don't fit into that create, read, update, and delete paradigm. And this is where kind of REST is just like, do your best and figure it out. um, there are some like official guidelines, but that get questionably followed. What tends to happen is if you have some sort of action that you want to add to a resource, you tend to do something like this. So going back to our car dealership example, let's say you wanted to add an action for when you sell a car. So a salesperson like sells a car, and what happens is like when you sell that car, maybe like the ownership of the car moves from like the dealership to a user, and maybe some like money exchanges hands or something like that. So that doesn't maybe directly fit into like create, read, update, or delete. I guess you could kind of make it update, but it's sort of like a more abstract version of update. It's like not change exactly the stuff. It's like perform this action and has a bunch of like behind the scenes things that it'll do. Like it might actually do a few updates behind the scenes. So in that kind of case, what commonly gets done is you'll sort of like just kind of follow the same path convention, but you'll often stick like a action on the end. So in this case, I'm making a post to car ID. So I'm targeting one item in that resource. And I'm have this like sell action. And I'm making a post request. Why? Because it seemed like that kind of made sense to me. It's like what I would use for this. Um, and then in the body, maybe I have some metadata about like who I'm selling it to and the price it's being sold at. But like this is kind of a place where like REST falls down a little bit, and you really have to rely on documentation that others will provide you. Um, but even like this case doesn't come up like constantly. Create, read, update, and delete, just those four, get you probably like 80% of the way there most of the time. Okay. There's also a concept in REST called nested resources. These can sometimes be really powerful. So just like we had before, like /cars and /cars car ID, you could also chain on the end more resources. So what would this do? This would be like cars car ID is like scoping your query kind of to like a car, and then maybe host on cars car ID owners. So this would be sort of like host owners. We're creating an owner. What this kind of would tend to mean is something like we're creating a new owner on a car. And similarly, you could kind of keep extending this to be like, if you define all these extra bits in your nested resource, then maybe you want to get details about a specific owner of a car. So maybe you make a request to this endpoint, you create a new owner on a car, you get that ID back. So you would get like this ID back when you do that. And then you'd pass that ID in here. So you'd be like, now give me or I guess you'd also have to put the car ID in here from above. So you'd be like, give me for this given car's car ID, give me information about this given owner's owner ID. So effectively what this is doing is sort of like filtering the data that is being returned back, the owner's data. You could think there's probably owners for all cars, but by doing it this way, you're saying only give me the owners for this specific car. So we're going to talk a little bit about this. There's a few different ways you can kind of go about filtering data in APIs. This is one approach of using nested resources to scope the results of future resources in the list based on the ones previous in the list. And you can chain these as far as you want. It's pretty rare that it would like go beyond like 3. It'll happen, but it's like pretty rare. really 2 is about as far as you see like regularly. Any questions about nested resources? Okay. So further on that topic of filtering, filtering in general is kind of a problem that is pretty common in REST, in particular when you're listing resources, listing data within a resource. So think about this. You have like a list of users, and you want to return all the users who have an email domain that's like example.com. So what you could do, one thing you could do, you could make a request to get/users, get back that list of users, and then once you've gotten that data on your client, kind of like we did yesterday with the number summing exercise, you could process that data. You could take that data, you could loop through it, you could pull out all the users that have their email that ends in a given string, or something like that. That would work. The challenge with that, though, is it doesn't tend to scale all that well. If you have a super long list of users, you got to fetch that entire list of users and then filter on the client. So you're sending a lot of data over the network and potentially causing the server to have to query a lot of data to give you that data back in the response. So really what you tend to want to do is you tend to want to do filtering server side. So somehow when you're making your request to the server, give it information so that it now knows how to filter and give you back the filtered data immediately in a response. In REST, the way you tend to do this is with query parameters. So we talked about query parameters a bit in the past. We're going to kind of really actually cover them now, though. So, but I guess real quick before that, this is kind of what it tends to look like. So let's say I wanted to do that email example because email domain. So let's say on this user's resource, someone's implemented an email domain filter. What you can do is you can include a query parameter, email domain equals example.com. And if the server supports that filter, it will use that to filter the data it gives you back and give you back just users that have that given email domain. Another pretty common filter is maybe you only want to return the first so many of your data. Like in this case, I only want to return the first 20 users. This might be a example way to do that. I guess I want to also call it like limit search, like the email domain thing. These are just like examples of filters. There's no list of filters that people say in REST you have to implement. It's kind of just like people implement whatever they think is important based off of the data they're serving. And it's sort of up to them to document it properly so you know about it. But they tend to go in query parameters when you have filters in REST. Okay. So how the query parameters get structured, when you have a query parameter in a URL, you have the path, and then after the path, you put a question mark, and then after that, you have a series of key value parameters. So you have, like in this case, would be search equals Ryan, and then limit equals 20. And those key value parameters end up being separated by an equal, so like search equals Ryan, and then between each parameter you have an ampersand. It's kind of a goofy format. Like the question mark and ampersand being different is a little weird because like then you have to be like you end up like repeating the ampersand over and over. The question mark's just one time at the beginning, so like this is not valid. It would be an ampersand there. So it's kind of weird, but it's just the way that it works, and it has a whole history as to why it's done that way. But so these query parameters are what you tend to use for filtering in REST. Okay. Any questions about filtering? Maybe like why it's important or how query parameters work? Okay. Let's do an example. I've done enough talking. I have a resource that I've defined on the careers and code.xyz server we've been using throughout this whole section. That gives me back, that's a user's resource. So I'm gonna go over into Postman. You're all welcome to follow along with me here if you'd like. And I'm gonna get a list of all the users in the system. So I'm gonna make a GET request. So I'm getting a list. So that's get slash resource name. So careers in code.xyz. And then for my resource name, it's users. I'm just going to start here. So I'm going to make this request. Okay. So when we get back here, it's in JSON. You can see in my response body or my response headers here, I have it in JSON. So let's take a look at this response and kind of see what it looks like. So at the root, it looks like we have this object. And then within there, we have this key data. And then inside of there, we have an array. It looks like that's kind of where our data is being stored. So if I like collapse this, it looks like those are all the keys that are in there. Then in the set array, we have a bunch of objects. So here's our first user. So it looks like this is Joshua McQueen, I think. Something like that. Lives in Lafayette, Louisiana. It's a great email domain, superito.com. Okay, so that's our first user. We have another user here. It looks like Lou Phillips, so on and so forth. But importantly, they all have the same keys. So just like we talked about yesterday, when you have arrays of objects representing like lists of data, you can see here our surname kind of lines up in all of them. They all kind of match. Okay, so cool, we've got that. Let's try filtering this. So the way that I've built this API, I'm just putting this out there because I don't have a documentation on this, so I gotta verbally say it. Every one of these keys in the object, the nested object, is a filter. And if you include it as a query parameter and set it equal to a value, it'll return you all the users that have that value set to what you've put in the query parameter. So as an example, I think on the slide I had city of Philly here. So I'll go city. So in particular, like city here is a column. So I guess real quick, I'll just go like, how many of these are there? So 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it looks like there's 10 that are being returned to us here, 10 users. So now if I go city equals Philly and come down here, how many would be returned? 1, 2. It looks like we just have 2. So it went from 10 to 2. So we filtered down that list. And now in here, city is Philly for that one. City is Philly for that one. That's an example of how a filter tends to work with a REST API. Any questions on that? Okay. If you want to on your own, you can play around. I believe all of these fields are valid filters. I think that's how I set it up. So you can play around with it if you want. Okay. So there's another really challenging thing that often has to happen when you build systems that send data from one system to another. What if you have lists you need to send from one system to another that are really long? So think of like a resource that has a lot of data in it. How do you deal with that? How do you send that data efficiently? So the example I have here on the slide is, imagine you want to return an array of all transactions that were made at Wegmans yesterday, like across all Wegmans stores. That's like a lot of data. Like just guess, like think in your head, like how many transactions do you think probably happens at a store every day? Let's say maybe like 20,000 or something like that. And that's like for one day for one store. Like imagine if there were a list of all of that data, like how big that list would be. Like easily like millions of rows per week or something like that. Like it gets intense how long that becomes. And if you think about it, like each of our JSON objects we were sending is maybe like, I don't know, maybe like 30, 40 characters or something, if like conservatively. So even like that, like 30, 40 characters times a million, you're very quickly getting into like pretty large sizes, pretty large amounts of data. So really, most of the time, you don't actually need to show all that data to a user. That's kind of the trick here. So why, like, if I come to you and I'm like, I need a list of all the data that was sent, all the transactions that were made at Wegmans yesterday, like the response that I should get from that is like, why do you need that data? Like, what do you need to like show that all to a user? Because if so, like that's like a massive list. Like a user is not going to be able to understand that. So in practice, it's very rare that you need large quantities like of data in a web application. It tends to be that really what you want most of the time is actually either a subset or like derived data from that data. In particular, that subset case is a pretty common one. So what you can imagine is like if you have like a big table of data, you might show the user like the first 10. And then maybe the user could press a little like next button and they could see the next 10 and the next 10 and sort of like go by tens through the whole data set. So in that case, you don't have to worry about making like this one massive request. You could make sort of smaller atomic requests that might over time end up returning, like if the user went through all the pages one by one, you could end up theoretically returning the whole data set. But because each request is small, it ends up being like not that much data that you're sending like per second. So you don't have some massive request that takes like hours to return data. You have a request that comes back quickly that just gives you what you need to show to a user as fast as possible. So this technique of sort of moving through the pages or moving through the data in blocks is called pagination. And it's a pretty common thing you'll see in REST APIs. So kind of as I just said, you tend to split, if you want to use pagination, if you have a resource that has a lot of data, the way this tends to work is you split up your data into chunks. And that chunk tends to be referred to, like the length of that chunk ends up being called something like your page size. And then which chunk you return back is something like your page number. So when you send data, make a request to the server, you make a request and you give it a page size and a page number. And for the server then can do some pretty simple multiplication, be like, okay, I'm on page 1. So usually like take your page number, you like subtract 1, and then you multiply it by your page size, and you sort of then like add a page size, and you get this sort of like window that's sort of like, I want to get data starting at 0 and going to page size. And I want to get data starting at page size, going to page size times 2. And kind of that sort of slides over in blocks. So there's the logic to implement this server side is not that crazy. But importantly, there's a pretty common convention in REST to do this. It also uses query parameters. So going back over here into Postman, to get rid of my city filter on that user's resource. So you'll notice that instead of this endpoint returning just like a single array, I've actually got this like wrapper object around it. And this is something that I tend to do if I'm building an API that has to support pagination. It sort of makes it a little bit easier to understand where you are in that pagination process. So in particular, this API endpoint, in this root object, I'm going to collapse data since we don't need to look at that right now. This total key here maps to the total number of records that can be returned by the endpoint. So in this case, there are 50 users in the resource. Page, this is telling me like what page I'm on. So I'm on page 1. And next page available is just a Boolean saying like, can I fetch the next page? Like, is there a next page? In other words, if I'm on the last page, this is going to be false. This isn't some convention that is like in REST. I just sort of made this up, but this is a relatively common of the kind of thing you'd see. And then data is the data that you care about. So if I wanted to, let's say, get the second page, actually, I should say real quick, I counted these before. There were only 10 items in data. So it looks like the page size that's default. I didn't set it explicitly, but it's just what it uses is 10. So it gave me 1 to 10, that first page. Let's say I want to get the second page. So if I go page equals 2 and click send, I'll get that second page. So just to prove it all to you, this works. The first one, it looks like the surname is McQueen. So if I click send here, now surname is Sturgis. You can see we're now getting the next sort of chunk of data. And I can kind of keep going here. So I'm going to go 3 and click send. Adams, 4, Ford, 5, Plotkin. Okay, so if you notice, now that I got page 5, we have 50, there's 10 per page. Notice this next page available now becomes false. If I try to fetch page 6, watch what happens. I get back nothing. So in other words, the server realized, you're trying to fetch a page that I can't actually give you because I don't actually have data for that page. So it could handle it in a few different ways. It could give you like a 400 in this case. I just decided to handle it in the case of like, just give me back an empty list. I believe, if I remember right, this also accepts a page size parameter I can use to change that page size. So I wanted to make this like 5 instead of 10. I think I can do this. Let's see. No, it might be it's page underscore. Page dash. I'm going to work through all the possibilities. No, I guess I can't customize it. I thought I had that in there. Whatever. In many systems, you can change that. So you can say like, I don't want to get them by 10s. I want to get them by 20s. And then what that will mean is like at the very end, you might have a partial page. So if you did it by 20 and you have 50 users, the first one's going to be 1 to 20. The next one's going to be 21 to 40. And the last page is going to be 41 to 50. So it's 10. It's just like, even if you try to fetch the page after that, you'd get nothing. So that tends to be how pagination works. Any questions about pagination? Okay. I guess I'll mention one more thing about pagination. There are other ways you can accomplish pagination. Right now, I'm just showing you sort of like probably the simplest and easiest to understand and probably the most common. But there are other approaches that have sort of different sets of trade-offs. This one here that I'm showing you is probably the most common, though, you'll see. Okay. So generally, I want, like, these are kind of the takeaways I'm hoping you'll get from what I've discussed here. REST is a good set of defaults. So if you are building an API, using REST as a framework to base the way you're going to organize your API on makes a lot of sense. It's going to make your API way easier to understand from a third-party perspective. But REST mostly assumes kind of like a perfect world where all you do on resources is perform CRUD actions. That's not always how the world works. Like there are sometimes weird edge cases you have to do unusual things. So because of that, like as an API author, you tend to want to follow REST principles when you can. If you can't, it's fine, but do it intentionally and in targeted ways for small parts of your API. So don't make exceptions the norm, make them actually exceptional. Okay. So that is actually the entire like lecturing part of today's class. The rest of class, I have a bunch of exercises to go through. And then on top of that, I also have some, we're going to get started on the New York Times thing, get you all set up on that. So when you leave class today, you'll sort of have a good starting point on that to kind of work on your own. Before I get into the exercises, though, any questions on anything I've talked about today? Okay, cool.
Actually, I do have a question.
Yeah.
When I was like messing around with Postman, I put the question mark sign, but age I put like 30. I mean, yeah, 30, but like the thing about it, like it gave me like all the ages, but it gave me like 30 and like over like 30. Is that like right? Or how did
Well,
that work?
so I will admit to you, it's been a long time since I looked at the code for that API, probably at least a year and a half. So I don't remember exactly how I wrote it, but I think this does bring up a good point, which is like those sorts of filters, they how they work is totally dependent on how the server side implementer built them. So you could like what you might find, and this is a pretty common thing, is you're using some sort of API system and you're like, "Ooh, I could use this filter to filter down the data to only get the data I want." And you try it, and it actually doesn't give you what you want. And you have to then like start to think critically and be like, okay, is there some other combination of filters I can use to try to filter down my data to minimize what the server is going to send me, to sort of like use as a proxy for the filter I actually want to use. So it ends up not being always the best, but this is where API documentation can come in and kind of help you figure out exactly how you would, what filters you can and can't use. And this documentation will often like explain to you what a filter does. This is a bit hard because I don't have any documentation for that API. It's all up here. So, and actually it's not even up here anymore. It's like, it was up here like a year and a half ago. Um, So if you're really curious, I can dig through the code and answer that. But that's kind of the answer. Cool. Any other questions? Okay. So we have quite a lot of exercises. You can see on the side here, I'm just kind of scrolling through all of them. So 321 to, yeah, we have like probably like 15 slides we can go through. I think what I'm probably going to do is I'm going to start going through them until maybe like we hit a good breaking point. We'll take a break, we'll come back, we'll keep working on them. And then once you all are like either tired of it or want to move on, we'll go to the New York Times thing. So, okay. So I have made some resources on the careers and code that XYZ server. We saw the users one already, but these resources here that we're going to use for the exercises have all the different CRUD operations implemented on them. So you can do creations, reads, updates, and deletes. There are two resources, students and assignments. So the student resource has 3 fields in it: name, current cohort, and favorite color. Also, for what it's worth, I'm going to take a screenshot of this, put this on the exercises, so you can refer to this, back to this if you need to, if you don't have it up on your system. But this is just sort of the overview. This is going to be kind of common information for a bunch of these exercises. So students have name, current cohort, and favorite color. So name is just a string. Current cohort is a number indicating the cohort you're in. Should be for everyone here, 6. And then favorite color is just a string representing your favorite color or the student's favorite color. So here's an example of what an example student might look like. So you have name John Smith, current cohort, in this case it's 4. For you, I guess it would be 6. And then favorite color, red. Assignments is the other resource. Assignments has name and completed. So it just has those 2 fields. Name is the name of the assignment, just a string. And then completed is a Boolean indicating if the assignment's complete or not. So Boolean being true or false. So here's an example here of an assignment. So name, rest exercises, completed, false. And then maybe once you're done with it, you can make it true. Any questions on the resources and kind of what the fields mean or anything like that before we get started? Okay. So let me see how I'm going to do this. I'm going to take a screenshot of this. Actually, I'm going to do that. I got to move that out of the way. Okay. I'll try my best to include that in here. Sorry, I should have done this ahead of time. I didn't quite think through this as well as I should have. Okay. Yeah, there we go. So for the first exercise, I should also say we're going to make, these are all requests that probably make the most sense to do in Postman. So get Postman started up and get ready to go there. There is a student's resource that I've made, and it allows the management of students that are in the class. So this resource follows all the REST patterns we've talked about today. So all I'm going to tell you is please create yourself as a student via this endpoint. And I'm not going to give you any more than that. Me just telling you there's a student's resource and that it's on careers and code.xyz, you should have everything else. And I guess also with this stuff down here, you should have everything else you need to make that request. So go for it. Give you a few minutes. Let me know if you have any questions. How's everybody doing? Okay. I'm seeing some thumbs ups. I'm seeing some head shakes. Does anybody want some more time? Okay, let's go through it then. So we have a student's resource, and we need to make a post to it. We're creating CRUD, create, post. So create means post/resource. So our student has a body. Name, current cohort, and favorite color are the keys that need to go in that body. So make an object, name, me, current cohort, 6, and then I think it was favorite color. Yeah, favorite color. I'll go like blue. So just got that object there with our keys and values. So names maps to a string, current cohort maps to a number, and favorite color maps to a string. Okay. You also probably should put a header in here, a content type header. I think my server is not super strict about that, but good habit to get into. Okay. So I've got the content type header, got the body, got the method, I've got the path URL. So I'm going to click send. This is what I get back. 201 created, so that's good. I get back this object, and within it, I have all the bits of metadata included, plus this ID field here. So I didn't say it, but make sure you save this. If you didn't save this for some reason, feel free to make the request again. You're going to need a user or a student ID field for a next exercise. So I'm going to copy that to my clipboard. Also, just out of curiosity, I'm going to make a get to students. So I said that I've implemented all the different things, all the different CRUD operations. Let's see who we got in here. So I'm making a get to /students, which is giving me a list of all the students available within the resource. Cool. Looks like somebody had an array of favorite colors they used. Not a big deal, but just like keep in mind that if my API was more strict, it might have given you back a 400 if you did that. But not going to matter for the exercises. Also, interestingly, some people put their 6 in quotes. So really, this is just supposed to be a number. I also don't think it's going to matter. I didn't really add a lot of validation to my API. I built it kind of quickly and was just trying to get something out there. So not that big of a deal. I'm just mentioning it because I just wanted to call it out so you all know that that isn't quite right, but it's good enough for now. Yeah, cool. Got a green, blue, the combination of black and white. Green, green, orange. Nice. Good spread. Okay. Any questions on that? Okay. I'm gonna take this and copy this over here again, just so we've got that. Okay. Within the students resource, there's a nested assignments resource. So this kind of thing. Please make an assignment for your created student. So you just made a student. I want you to make an assignment on the resource within your student. So give you a few minutes to do that, and let me know if you have any questions.
I have a question. Is this the reason why you wanted to save our ID so we could use our ID with the sign? Okay.
Yep, exactly. Yeah, if you lost your ID for some reason, feel free to just make another student. Like, you don't have to have one student. Like, you could make another one if you lost it. Or you could always make a GET request like I did and find your student in that list and pull out the ID. Okay, how's everybody doing with this one? Do folks want a few more minutes or you want me to go through it? Okay, I'm not hearing anyone adamantly looking like they want me to hold off a bit, so I think I'm just going to go through it. Okay. So, we need to create an assignment within our student resource on the assignments resource. So I'm going to make a new request here. I'm creating, so I need to make it a post. So careers and code XYZ/students, and then I'll need my student ID, and then assignments. There we go. So in this case, I'm accessing the student ID, or student with that given ID, and then accessing the assignments resource within. So I'm going to pull that ID from over here, substitute that in real quick. So it should look something kind of like that. Now in my body, I need to include the data of that, or the representation of that assignment to be able to create it. So I think it was like name, go like test assignment, and then completed false. I think that's what it was. Okay. Also going to include that content type header again. Okay. Post, student ID, assignments, the body, name, completed, headers, content type, application JSON. So if I click send now, I get something that looks like this. I get a 201 again, which is good. And then I get back name, completed, and there's another field I get in here with an ID, student ID. So you're going to talk about this in a few months when we get, I guess, a month and a half, some point like that. In the future, we talk a bit more about databases and how they tend to work. But in order to store this assignment being associated with the student, my API on the assignment stores a value called student ID. And this value ends up being equivalent to this value here. So using this is how the system's able to understand that this assignment goes within the student. So if I come over here and I make a new request and make the request to get a list of all the assignments, you're going to see it's just going to give me back this single assignment. And you all made assignments. So like there's a bunch of assignments in the system, but this is the only assignment associated with my student. Just to prove it to you all, I'm pretty sure I've actually got an assignments resource on the root that you can make a request to. Yeah, they'll return all of the different assignments everyone made. So just like before, we kind of can see what everyone did here. Someone made their assignment complete already, which I don't know what they did there, but I don't think your assignment's done yet, whoever that was. Oh, two people did it. Someone made it not yet. Keep in mind, completed is a Boolean. So if you were making this request and you didn't make it a Boolean, you might have gotten back a 400 from the server. My server is not very strict. They'll just accept whatever you give it right now. But keep in mind that in the real world, what you did here might not have actually worked. Yeah, other than that, oh, it looks like someone made a request to :student ID. So someone made a request to this. Keep in mind you need to substitute your ID in there. It's not :student ID. I guess I should have mentioned like that whole colon thing. This is a pretty common pattern you'll see when people talk about API endpoints. They use this little colon syntax like this to mean that you substitute in something in that location. So it means that like you would actually put in like ID here. So that's what that means. You'll see this a lot more once you actually start writing your own servers, which you'll do in like a month or so. But that's what that pattern means. So okay. Any questions on this creating the assignment? Okay, cool.
Yeah, I have a question.
Yeah.
For some reason, like mine's not working, even though I put like my ID on the excitement on post. Like, for some reason, it keep giving me cannot post to it, and then my ID, and it's like,
Yeah. You want to share your screen? We can take a look. Cool. You might be sharing the wrong screen. Oh, I see. Ah, so take a look closely at your URL there. So you made your path is students ID assignment. There's something a little off with that last word. You're close. There's one other thing too. You have a little spelling error there. Give that a shot. There we go. Very close. But
Thanks, Ryan.
yep,
It's always a spelling error for me.
no problem. You'll get better at it with time. Okay. So let's do something that's more than just a create. What I'd like you to do, you created that student. I'd like you to update the favorite color value on that student to something else, some other value. I know maybe you put in your favorite color. You got to pick another favorite color now. I'm sorry. Um, so change it with a put request. Give you a few minutes to do that. And ask me if you have any questions, let me know.
I got an error, but I can't understand why. Can I share my screen?
Yeah, go for it. Yeah. So take a look at your URL, particularly the path of the URL. So you just want to update the student. And when you have a REST resource, the path you want to use when you update is resource name /ID.
Okay. And not the favorite color part?
Yep. Yeah. See, that favorite color part, that isn't really what you should be doing.
Uh,
That's something you're defining in the body.
okay. Oh, I guess I don't exist.
Are you sure that's your ID?
I copied and pasted it. Let's see. Let's get it. Let's just get the students. Oh, I got a new one. Because at first I made two and then I deleted one.
Yeah. Okay. So it's probably the one you deleted.
Okay. I understand. Let's see. I'm gonna put it. Yay. And I
Cool.
also have another question.
Yeah.
So, I actually added my old ID to the list of students by mistake, and I want to try to delete it, but I did not do it right. Like you see down here, it's just like a ID floating. Oh wait, where is it? Right here.
Yeah.
I
So
didn't
you
mean
should be
to.
able, if you made a delete to slash students slash that ID, that should delete it.
All right, let's see.
It's also possible there's some bug in my API, but I think that probably should work.
It
Yeah,
worked.
cool. So if you
Thank you.
made that GET request again, it shouldn't be in there anymore.
Oh, why did that happen?
Postman sometimes auto completes in weird ways.
Yeah.
Yeah,
Oh
nice.
no, it's
Oh,
there. Oh no, no,
no,
that's
no.
someone else.
Yeah, that's someone else's.
Okay, yeah, it went away.
Cool. Okay,
Thank you.
nice. Okay. Am I good to go through it, or do you all want a little more time? Okay, let's do it. Okay. In this case, I'm updating my favorite color. So I'm gonna students, and then something like that. Want to use a put, so I'm updating students of that ID. So now there's an important thing that I guess I just want to call out. The way I've built my API, it accepts a few different things you can put in the body for your update. So the strictest possible thing, like what you should do according to the specification. Need to get my user here. What you should do is pass something like this. I'll make this like green. So importantly, I'm including all the different fields. So name, current cohort, favorite color. I've only changed one, but I'm duplicating all the fields. In the strictest REST sense, this is what you should do here. You're making an update, so you need to give it the entire new data you want to update. So I'm going to click send here. And there we go. We got a 200. It's green. Now, some folks, you might have just done this. Now, you've heard me mention a few times this thing where I've been like, there's another method called patch. There's like a put and a patch, and they both kind of do updates. This is what the difference is. So in the like strictest sense, a put is an update where you give it the entire object, and a patch is an update where you give it just the things you want to change. They have different methods. So there's like a patch method over here. I forget if my API supports patches. It might, but it's pretty common for APIs to follow the philosophy of what's called a put is a patch. Because if you have a patch that is like contains the full object, it's the exact same thing as a put. So a lot of APIs will just effectively make them the same operation. So like literally, no matter the method you call, it just runs the same code on the server. Some will only support one, some will only support the other. So the way I built this, puts and patches are the same, or I forget if it was a patch endpoint, but like you can give a put a partial document or partial like object, and it will be able to work with that. Um, that's not an uncommon thing. A lot of APIs will do that, but I just want to call it out because that's not always how it works. In the strictest possible sense, this is what you should be sending, and some APIs really will require you to do that. So that's the only real like gotcha. Other than that, I mean, I'm assuming this was relatively straightforward for folks. Any questions?
So the thing to remember is put is when you're changing the entire like thing, and patches is only when you like change like one thing. Like for example, like
Yeah,
favorite color is like yellow, or change it to
yeah. But importantly, that's in like the specification. In practice, often the way people implement it, put and patch just do the exact same thing. Cool. So Joe asked, what's the point of the two of them then? Was patch intended to be used for singular updates? Um, I actually don't really know the history, and I probably should know about like how that evolved. What I'll say is there are cases where if they put and patch are implemented distinctly, they can actually be really helpful. So a great example, let's say you want to like you have a field in your data that is like nullable or like can be set or unset. And maybe the way you unset it is you just remove it from the object. So it's like it exists there or it doesn't exist there. Now, if you think through it, like if you have tried to do a patch and you don't include that because you want to remove it, then it's just going to not change it. But in practice, like a put, if you didn't have it there in the strictest possible rest sense, like that actually means like get rid of it. So sometimes it can have an important semantic difference. Like what I'm explaining here, like this sort of scenario is like way off the deep end of like things you ever really encounter. In practice, like 99.9999% of the time, it just doesn't matter. They do the same thing because most of the time, if you in that case, you'd represent it by like making the thing nullable or something. And in that case, you just set it to be null. That sort of handles your explicit unset value. You can do that in a patch and it's fine. But I guess that's an example of like a case where them being different actually does kind of matter. Cool. Any other questions? Okay. So we've got one more here, and I think we're going to take our break. It's just these first four here all kind of fit into the same logical category. So I think we'll do this last one. Should be pretty fast. We'll take our break, and then after the break, we'll actually be able to start talking to some real APIs, not just some stuff I wrote. So the last one here is just like we did with updating the student. I want you to update your assignment. And I want you, now that we're done with our assignment, for you to change the complete Boolean from false to true. So we're done. Now you can actually mark it as you're done. So give that a shot. Let me know if you have any questions.
Okay, I have another error I can't identify. I'm thinking it's the way I did my path. I'm not sure if it's out of order.
Want to share your screen?
Oh, I'm not. Oh, I thought I did. Sorry.
Ah, yeah. So keep in mind here that assignments is a nested resource. I
So I
think
need to add students first
you do.
and then
So
assignments.
I might not have added, I had like a assignments list at the root. I might not have actually fully implemented that. So it's students, but remember the way it worked before, students ID assignments.
Mm.
So well,
Mm.
students ID assignments assignment ID. So sort of like breaking down that resource, you have the first part, which is sort of the limitation to students, and the
Mhm.
second part, sort of like the limitation to assignments. So the two kind of different resources.
Oh, and then the ID after you go into the assignments.
Yep. So think of it like you're traversing into it. So you're like traversing into
Oh,
everything that the student has, and then you're accessing the assignment within the student that has that ID. So you're going to need your student ID for this.
oh, that's not it. I need to put student ID, the words.
No, so if that's your student ID there, you want to put that after /students, but you also, so I guess you need your student ID and also your assignment ID. I guess I didn't mention you got to keep the assignment or ID around too. You're gonna need your assignment ID for this.
Oh, I gotta go find
Um,
that. I gotta look
yep,
at
if you
it.
need to find that, you should be able to make a get to
Get to
/students
assignments.
and be able to find it nested in the students response.
Oh, okay.
Or /students, student ID /assignments. Kind of go either way.
What? Mhm.
Hi. I'm tempted to go through it here. Anybody want any more time? Okay, let's do it. And then we'll take our break. So I also didn't keep around my assignment ID, I don't think. So I'm gonna need to get that. Probably the easiest way for me to get that is to make a request to students, student ID, assignments. And because this is the nested resource within students, I'm getting all the assignments associated with the given student. So if I do this, you'll see I have one assignment here. I've got ID and student ID. I want ID. So I'm going to pull this out, this ID. Now I want to update that assignment. So in order to do that, assignments is a nested resource within students. So I'm going to go students, student ID, assignments, assignment ID. So now I'm accessing the assignment within the nested student. I'm also going to need to now put a body here. So the name of my assignment, I think, was rest exercises. Let's see, test assignment. Someone else did rest exercises. And then I need to set according to the exercise, you need to set completed from false to true. So I'm going to make this true. Also going to make sure I have that content type header. Now, I'm going to click send. So you'll see after I made this request, got completed, set to true. In the response, we've got a 200 OK. So it looks like things worked as we expected. Just to verify it though, let me go back over to my other request. So this was the first request I made to look at all of my assignments to get that ID. If I send this off again, you'll see this false here should go to true. So it's because I'm querying the same thing, I'm accessing that same data. So now it's true. Any questions on that?
Yeah, I still can't get the list of assignments. I don't know what I'm doing wrong. I put my student ID and it didn't work, so I took it out and it still didn't work.
Do you want to share your screen? You can take a look. Okay. Yeah, stick that student's ID back in between where you think it should go. Yeah.
Give me nothing.
Are you sure that's your student ID?
It was the new one. Remember I had an old one and then I got a new one? I think I got a
Did
new
you,
one.
when you created the assignment originally, did you create that assignment on the
Oh,
old user or the new user?
I did it on the old user.
That's why then, yeah. So if you
Okay.
want to go through this, you're going to have to make the assignment on the new user and then update that.
Okay. Put students. And should I add assignments at the end of this?
Yep, you're going to want to do that, yeah. Keep in mind here, though, you're making a put. Probably you want to make a post if you want to create.
Oh, no. I think that's what I was doing wrong. I was mixing up.
So
Oh, okay.
keep in mind here, we're creating. So we're kind of redoing one of the earlier exercises. If you wanted to update this, you would, I mean, I think you're headed in the right direction here. So I'll let you just work it for a second.
Then I have to change this.
You don't want to change that. So you've got the student ID is there is fine. You want to add your assignment ID to the assignments part of the path. So you see there how you went from students, student ID, assignments, assignment ID. You're sort of like traversing through each resource by its ID. It says no such assignment with student ID that and assignment ID that exists. So
oh wait, I think I put the wrong. Oh wait.
yeah, you put the same ID in both.
Okay.
You see how the student ID and the assignment ID are the same value?
Yeah. All right, I need to get it again then.
So wait, so excitement has its own ID, but we also have put our student ID. Okay.
Yeah. So every assignment is associated with a student. So because it's associated with a student, in order to actually access it through the API, assignments is a nested resource under the student. So you can only access data about an assignment in the context of a student.
So is it like that with the New York Times thing where like each book got its own like set of IDs and is nested within like a
So
list?
in the New York Times exercise and in most APIs, every entities will have unique identifiers for each one. The New York Times API in particular, I don't think has a nested resource necessarily in, well, yeah, I don't think I would necessarily think of it that way. The path is a little bit more complicated, but I wouldn't think of like a nested resource, more of just like there's a prefix in front of the resource name. Um, yeah, The GitHub API, though, we're going to use after our break. That does have some nested resources involved. It's a pattern you'll see used sometimes. I wanted to cover it just because I want you to know it exists. It's not something you're always going to see, but like it comes up sometimes.
I did
Okay.
it.
You did it? Excellent. Let's go through it then. Okay. So I want to change my assignment and make it complete. So I'm going to go assignments/assignment ID. So I got that from here. Update my body and make completed true. Still have this header content type in there. I need to make this a put. So put students, student ID, assignments, assignment ID, name completed in the body. Got my header there. So if I click send, got completed there now to true. And if I were to go over, where was it? Yeah, this works. If I did a get, now I got true there. So I updated it successfully. Okay, so yes, I gotta do attendance. I've got like the last attendance word. Oh gosh.
Rest.
Rest. Yeah, I like it. Nice and easy. Okay. So let's take a break. Let's get back at like maybe like 7:50 or so. I think that's about half an hour. And then we will work with some real APIs for like 20, 30 minutes. And then we're good. So see you all at 8:50. I knew I'd forget that at some point. Okay, to repeat what I just said for the recording, up until now, we've made requests to API endpoints that I've put together as examples. And that's mostly because I've tried to simplify things so we could go step by step piecemeal through what we needed to get through. But now we've covered enough where we can actually make real API requests to real endpoints, like actual real third-party things. So we're going to spend the next half an hour or so making a request to GitHub's API. So you all are familiar with GitHub, the place where the code repository hosting service that you've all probably used a fair amount at this point. So they have a third-party REST API, and we're going to use it to do some things and get some practice using a real API service. Let me share my screen here. Oops. Yeah, there we go. Cool. It was on the right thing. So we're going to be using the GitHub API to do these next few exercises. So in the slides, and I'll put this in the chat as well, I've linked GitHub's API documentation. So most APIs you will encounter in the real world, real web APIs, have documentation. You don't just have to figure this stuff out on your own. Someone's gone through and given you sort of the requirements you need for the request you're going to make to that service. So if I click on this link, we're now in GitHub's API documentation. To give you sort of a bit of a tour through this, just so you kind of know how to navigate this, this is pretty relatively common looking API documentation. There will be usually some sort of quick start page, which can often be a helpful thing when you're getting started, sort of explaining to you how you exactly would do it. So got all our methods here, and it's talking about, got maybe some nested resources here. Talking about some custom headers you might need to specify. So you can read all through those on your own if you want. However, on the left here, in this big list, is a list of all of the resources that GitHub has within it. So as an example here, I have this branches resource. So you can see here, there's this branches resource that's available under repos, owner, repo, branches. So if you made a request to this, you could get you could list all the branches on a repository, for example. And you can sort of go through these and scroll through the list, and it'll give you sort of exactly what you need in order to make that request. So a few things I want to call out, though, on some of these. It's going to give you a list of the headers and query parameters you need to specify with little explanations as to what they mean. So you can read through this and be like, oh, okay, this is exactly what I need to send. You're also going to see on the right here, it gives you a curl. So you can take this, you can copy this, and bring it into Postman and have it automatically import the curl and have the request in there and give it a shot. So this is a great example of where that curl stuff I talked about a couple weeks ago comes in. Many API documentation tools will have curls you can just copy and paste. Also, I have a little example response here. So this is an example of what the data that comes back from the API should look like, and it should give you a 200. It'll tell you, like, these are the different status codes this API response, or this API endpoint can return. It's got a big list of all these different endpoints in here. And they all sort of do different things. So that's kind of high level what GitHub's API documentation looks like. If anyone has any questions, feel free to ask. But if not, we'll probably just get started with the first exercise. Oh, there's one other thing we have to do. GitHub's API requires an API token. So going back to earlier this week, tokens are coming back. So we're going to need to make an API token on GitHub. This is something everyone's going to have to do themselves. So you can follow along with me here. We can kind of do it together. So I'm going to copy this link. I'm going to paste it in the chat. You're going to want to go to this. You might need to put in some GitHub credentials. Let me do that here. One moment. Okay. So if you have your credentials all set up properly, you should see something like this when you click on the link. To explain like where this is in GitHub, you can go over to the side here and there's a settings thing. If you go into here and you go down to developer settings, and then you go to personal access tokens and tokens classic, and then click generate classic. So with GitHub, they have their new tokens and their classic tokens. I'm just going to be on classic tokens work, so it's just what we're using. Their new tokens have some different permission model stuff that I haven't really dug into deeply. So, but that's how you can sort of get to this page by clicking through GitHub's interface. You can just click on the link in the slide. Oh, say that
Real
again?
quickly, upon trying to put click on generate token, I was given an error message of note can't be blank.
Ah, yeah. So you went down here and you clicked generate.
Mm-hmm.
Yeah. So don't do that quite yet. We got to click a couple
Okay.
things in this form before you're getting a little ahead of me. It's fine.
All
But
right, fair enough.
yep.
So can you show me how to get to it, how to navigate to it from the repository again, or like from your dashboard?
Yeah. I mean, the easiest way is you just click on this link or the link I put in the chat. But if you want to get to it from GitHub, go up into the corner, go to settings, and then under settings, go down to developer settings on the left, go to personal access tokens and go to tokens classic, and then generate new token and tokens classic.
Thank you.
Yep. Okay. So this is just the obligatory reminder. We're generating a token here. These things are secret. You shouldn't share them with people. In fact, if you give someone this token, they're going to be able to basically impersonate you on GitHub. So that wouldn't be good. So don't do that. If you're really paranoid about it, after we do this, you can delete the token in GitHub, and that'll make it invalid, no longer work. So, okay, the things you have to do in here, and this is also on the slide. You have to give it any sort of name in the note thing. I'm just going to call this careers in code. Doesn't matter. You can call it whatever you want. You just have to put something in that box. And then under select scopes, you're going to want to check this repo box here. Not any of the ones below here, the top level repo one. It says full control of private repositories. So what this is doing is giving this token the ability to do anything with any of your repositories on GitHub. Once you've done that, then at the bottom left here, you can click Generate Token. And what you'll get is something that looks kind of like this. So give folks a second. Just do that. Don't want to lose anybody. Okay. Once you've generated this token, this value here, you're going to want to keep this around. Once you refresh this page, this value is going to go away. This is the only time you're going to see it. So copy it to your clipboard, do whatever you want. I'm just going to keep this tab open in my web browser. But just like know that if you refresh the page, it's going to go away and you're never going to be able to see it again. So you only have this one chance to grab it. This is the token value we're going to be using when we make requests to GitHub's API. So this is going to go in that authorization header with that bearer thing we talked about earlier in the week. One other thing I'm just going to say, I'm cognizant this is being recorded. I'm cognizant somebody could look at the recording and steal this off of my screen and impersonate me on GitHub. So I'm just putting out there, once I'm done with this class, I'm deleting this token. It's going to be invalid. It's not going to do anything. So good, you can try that if you want, but good luck, attacker. It's not going to do anything. Just got to say that, okay? But anyway. Okay, so we got our token there. Anybody having difficulty generating their token still?
I was locked out of my GitHub account for a minute. I got back in. So can you just, I'm at the create a token page.
Yep. So I'll go back over here. So you need to you can put whatever you want in Note, doesn't matter. And then you want to check this repo box, the top level repo box. And after you do that, at the very bottom, click Generate Token. That's all you have to do. And that'll bring you here.
Do I need to put something in the note or can I leave it blank?
You have to put something in it, but it can do whatever you want. I called mine careers in code. Okay.
And you said we have to like copy it and put it like somewhere.
Yeah, so what I'm going to do, because I'm just using this token right now and I'm delete it in like half an hour, I'm going to have this tab open and I'm just going to keep it there and just not be sure not to refresh this tab. If you're worried about it, you could take a copy of your clipboard, put it in some file somewhere. Importantly, like once you refresh this page, you're not going to be able to see this value again. So just make sure, like keep that in mind. And we're going to need this a bunch of times in the next like half an hour or so. So just like you can do whatever you want, just like you're going to need to access it over and over. Just make sure you don't lose a copy of it. Cool. Okay. So this first one, I think we're going to do together, just because I want to give you sort of an idea of how it tends to go when you're looking at API documentation. So the first exercise is how many public repositories does the Hack Upstate organization on GitHub have? And I've given a link here to Hack Upstate. So trying to figure out the number of public repositories. So I'm going to go back over to the GitHub docs and just going to start looking around. So there were a couple different like potentially resource sounding words in this exercise. Repositories and organization. Those both sort of to me seem like things that I might be able to query to get like number of public repositories. So kind of my thinking there is if I could like make a request to get like all the repositories associated with an organization, I could just like count the number of results. I could do it that way. Or maybe there's like some sort of data on the organization, like some sort of value that's like number of public repositories. So those are kind of two different potential like entry points. So I'm going to start with repositories. I'm scroll on the left here. We've got repositories. I'm going to click on this. I'm going to look through here and see if I can find anything that looks, ooh, list organization repositories. That looks exciting. Okay. So it looks like I need to make a request to api.github.com/orgs/org/repos. And now kind of the question is, what's this org thing? So like maybe I can look at the response here. Is there any sort of hint as to what that might be? Well, let's do this. Let's sort of get this request. Let's try to sort of get it ready to go. We could just play some trial and error, see how it goes. You will discover as you do more and more of this, there's a lot of trial and error in this kind of work. You're looking at the documentation, you're thinking, I think this might be how it works. And then you try it, and then it doesn't work. And you try it again and again and again. You smash your head on the wall a few times, try it again and again and again. And eventually, after doing it like a bunch of times, you come across some permutation that works. So let's try this here. So I need to make a GET request. So it looks like there's a repos resource. Take this and do that. Okay. So we've got some headers. I got to include this accept header here. I'm not really that worried about like what this stuff means. Like it's just I'm seeing it in the documentation, so I'm just like, okay, I'm gonna have to include it. It looks like there's some custom header GitHub path that starts with an X, so I'll take that, get that over here. Okay, and then authorization. And then I need my token. So your token. I'll take this, I'll copy that. Oops. And then I will put it there. Okay. So now we've replicated that curl. Let's try to make this request just as is and see what happens. Okay. So good news and bad news. Good news is we made the request and we got back something. So that's good. The bad news is it looks like we got a 404 not found. So it starts with a 4, so it means something in our request isn't quite right. And my chief sort of guess is it's this org thing. Because that seems like that's supposed to be like the ID part of like the orgs thing. Like that's orgs ID repos. That's like a nested resource. So I need some sort of like ID. So maybe I can like, I'm seeing down here in the response, there's like owner here, and there's like an ID there. Maybe I could like try that. So like I'll try like 1 maybe, see what that does. Didn't seem like it worked. Okay. What else could I try? I could maybe try like some sort of, well, there's like I have to somehow get hack upstate in there. So maybe like I need something from like the hack upstate entity to stick in there, like its ID or something like that. I will say one thing that I did notice, this was just like, I clicked on this link and I was taking a look at it. Like there's sort of a like ID up here in the URL or something like that. It's like hack upstate. I could maybe like try that. Like that's something that's sort of like something that's like, I know that points to hack upstate because if I put something else here, that would go to a different page on GitHub. So like I know that that's like related to HackUpstate. So I guess like they'll try that maybe. So let's try like this. Okay, that's exciting. I got back a 200 with some stuff in there. Okay. So I guess now that I'm seeing this, I'm seeing that this thing here tends to line up with like the login and like the prefix here. So it sounds like I got that right. Also, there's a lot of HackUpstate stuff in these like URLs that are in here. So I think I'm feeling pretty confident that I got that right. That's just a guess. We're kind of like working through this step by step. So going back to kind of the original question, how many public repositories does the HackUpstate organization on GitHub have? So I see there's this private field. So I guess one thing I could do is I could just go through here and just count everything where private is false, like manually. But I'm not really like, really what I should be doing is I should be filtering at the API level. Because if HackUpstate had like hundreds of thousands of repositories, I don't want to download all that data to my computer. So really I want to filter on the server somehow. So let's take a look at the documentation again. So list organization repositories. Okay, headers, path parameters. Oh, yeah, we could have stole it from there too. Org, the organization name. So I guess that's another way we could have figured out what that org thing meant. Query parameters. Okay, so query parameters usually some sort of filtering mechanism in REST. So I see a few things here: sort, direction, type, per page. Okay, so it looks like the API is paginated. That's good to know. So we've got this page, we've got per page. So per page is like our page size, and page is like which chunk we're looking at. Looks like there's some way we can sort the data. So we can like pick a sort order of the data we get back. That's kind of cool. This type thing, though, seems interesting. Specifies the types of repositories you want returned. It can be one of all, public, private, or some other stuff. We want public. Maybe type public. So if I do like type public, what does that do? So, okay, private false. Any of these private true? No, false. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, it looks like there's 24 repositories. This array has 24 items in it that were returned back. So to me, it seems like there are 24 public repositories on GitHub. Okay, so that was probably a little overwhelming. API documentation, so like kind of what I went through here, this like parsing it and like laying around like doing trial and error with it is a skill that you just sort of like get better at over time. I've been doing this for a while, so I've done a lot of this, but don't feel bad if you're like spending a lot of time just like trying things, because fundamentally, like there's some shortcuts and some tricks, but that's really about what it is, like what the process involves. The better the documentation you have, of course, the better it tends to go, but like it is kind of what it is there. Okay. Any questions on what we just did?
Yes. Is there some sort of syntax you can use to like just return the number of like public false?
That's a good idea. A good question. There's nothing like built in, like it's kind of all up to what GitHub's defined. It doesn't look like they have a way to do that in this response directly, but something we could explore. There was that other entity, organization. I really have no idea if this is going to work. Let's see. So if we go over to organizations, they're like repositories for an organization or something, or get an organization. Yeah, okay. So look at this. If we get an organization, so this is orgs org, in the response, there is a public repos value that maps to a number. So another way we could probably do this, let's see if we get the same
Nice.
value 24. We could go over here. We could make a get to this instead. There we go, 24. Nice. Good suggestion.
But just a quick thing in that example, well, one, it didn't seem like they followed the common standard of putting the colon and then whatever term that you want substituted. I remember you mentioning that earlier.
Yeah.
So that was interesting that you just kind of figured that that's something that we had to sub in for, given the experience I can imagine. But also, I think that I saw a caret or like a bracket, and I was wondering what that was.
Yeah. Let me go back over to, so you're talking about like
Right there in the
this.
get orgs bracket, or does that, we don't necessarily care for that. Next to the get logo.
Oh, yeah. So that colon syntax, this is another thing where there's a couple different ways it gets done. So the reason why mine jumped to that, you're right, is kind of partially due to experience. But I'll also say that just generally knowing that there's the pattern of like you have a resource name and then after it like an ID. It's really common with API endpoints to have something where it's like resource name ID, and they sort of like alternate. So when I see something like this, I see orgs, I see this, and then I see repos. This to me doesn't look like a resource name. It's sort of like it has like fancy symbols in it. So to me, like that makes me suspicious that an ID might go there or something that I might need to put there. Also, just that here and here, those are like two different versions that sort of spell it out differently. Like also tells me that this, like literally those characters probably aren't important to the request. So it's sort of like a lot of little context clues that kind of generally lead me to the assumption that that's what I need to do. But like, there's no way to know for sure. Like you're sort of just trying your best to interpret the documentation. And you might get to a point where like you're thinking, oh, an ID goes there, and then like you're like half an hour into it, and you're like, wait a second, maybe an ID doesn't go there. Maybe that I need that literal text, and because you're just like that's something you want to experiment with to try to see if you can get it to work. So I realize that's not the best answer, but it's kind of just how a lot of this stuff goes.
No, it does make sense. Thank you. And I
Yep.
do think I have a follow-up question. So
Yeah.
Postman is also making sense to me at this point. I'm just kind of trying to see how it all connects when creating, you know, a full stack development like website.
Yeah. So the exercise we did yesterday, we made that request to that number list endpoint, got that data back, did some processing on it in the web browser, and logged out the sum of the numbers. Imagine instead of us making a request to that number list endpoint, we made a request to one of these GitHub endpoints. And instead of summing up the numbers, we like maybe did something like counted the number of items in that array. So kind of the place where I'm hoping it'll connect for you all is this idea of making requests to an API in a web application, getting back that data and showing it to a user, that sort of core interaction. That's something that you do all the time as a web developer. And that's basically what the New York Times exercise is. So the thought here is we've gone through that sort of whole pattern with a API endpoint I've made. Now, let's try to do it with an API endpoint that someone else has made that actually has real interesting data in it. Does that make sense?
Yes, it does. I think that, sorry, my connection question was a bit not as coherent as I had hoped. I meant insofar as, creating the JavaScript and JSON files to then, I think you kind of spoke on this yesterday, but perhaps this is something I should ask you like in a office hours kind of setting. But yeah. So no worries, never mind.
Yeah, sure. That exercise we did yesterday, at the very end, that number list thing, that's very close to kind of what you're expected to do at the very end of the couple weeks. So, um, cool. Well, I am trying to be a little cognizant of time. We're kind of burning through it a bit faster than I thought we would. Let's do at least one of these. I want you all to try it, at least one of these. Um, And I think we're going to go over a little bit again today, and I'm sorry about that. But after we do this one here, I want to get you all started on the New York Times exercise. We're going to generate your New York Times token and all that stuff, just because it's a little bit annoying to do that. I just want to walk you all through it in a communal setting. So give this one a shot. So the goal here is you need to start by looking at the API documentation and figure out how you would create a new repository. And then using the specification of the documentation, create that repository using Postman. So make the request you need to make and make your repository called GitHub API test. So give that a shot. Let me know if you have any questions. Can anyone hear me? I'm not exactly sure what just happened. Hmm.
You were MIA for a bit there.
Yeah, I Zoom just like completely quit, like force quit, and I don't know what I did. So I'm back. Sorry about that. Has anyone been able to find the API endpoint you need to use to create a repository?
Good question about that.
Mhm.
So I see one that's what I've been basically using. Create a repository in an organization. And can I make a repository like in my own account? Am I considered an organization or?
Um, you are not. So something worth knowing about GitHub, they sort of have organizations and users, and they're sort of two distinct entities, and they have sort of separate endpoints that operate sort of on each type of each sphere. So in particular, you're looking for a way to create a repository on a user.
Okay.
Um, I'll help you all out a little bit though. So
Oh, get a repository. No, that's get a repository.
I'm gonna scroll down here. So I'm in
I,
repository. I think everyone's probably gotten to the point of like repository is probably the resource you want to use. So I'm gonna scroll down here. I'm just gonna look through all these. I see create an attestation, create a repository, list, list, create a repository. What I'm gonna do, I'm just gonna go create. Create a repository for the authenticated user. That sounds like what you want. So if I scroll all the way down here, it's second from the last from the bottom. At least that seems like what you want. What do you all think?
so does authenticated in the GitHub terms, do they mean like we already have a token? Because I thought maybe like that was also something special.
But typically, kind of going back to some of what we talked about earlier this week, authenticated means you are a user who is logged in and have access to the system.
Oh,
So
okay.
to me, when I see this, what this kind of translates to in my head is create a repository for the user that the token is associated with.
Hmm. Okay. Thank you.
Yep. So hopefully that maybe unblocks some of you all. Give this one a shot with this endpoint.
I got a question about the version.
Yeah.
So is that just like putting in today's date and we'll find the most current version from that date?
So it's a good question. API versioning, sort of the idea there is sometimes you might want to have different sets of API endpoints that allow you to make sort of hard fork changes in how an API works. So every API does versioning differently. I didn't really talk about it because it tends to not usually be that big of a deal. Usually what'll just happen is you'll just have like a path prefix at the beginning. So like /v1/ before everything, something like that. That's the most common way. GitHub does a bit of an unusual approach here that some other larger companies do, which is they version with a header like this. So the date that you specify is sort of like the date of the version of the code that was released. So let's say they release like a new version of their API. That new version of the API, like maybe it would be like 2024 6/11. So that's what you would put there. But because the API is like seems to be for their 2022 11/28 API version, that's the date you want to put there and you don't want to change that. So think of that as like version 1. If you change it to something
Gotcha.
else, it's not going to work anymore.
Okay, yeah, that makes more sense. I've used Google Civic Info API once, and their most current one is V2. So I've seen that with the prefix
Yeah,
V2/whatever.
that's a
Okay.
lot more common. I'll also say, just like as an aside, as an engineer, to build an API like this, where you're versioning things based on dates, is a lot more complicated to build. So I don't really understand why they did it this way, but it's what they did. So, um, okay. How's everybody doing with this? Has anybody been able to get the request into Postman? Sounds like that might be a no.
No, I haven't. I keep getting like 404. I'm trying to figure it out.
Well, so it sounds like you've at least filled out Postman. You're sort of in the trial and error phase. Okay, cool. Um, is there anyone in that phase who would like to share your screen and we can work through it? I can do it on my end, but I think it's less exciting.
Wait, you mean somebody who like did it or?
No, like if you're still having trouble and you want me to help you through it. Because if I help you through it, everyone else is going to see and we're all going to get through it together.
Oh, I don't. Yeah, I don't mind sharing my screen.
Cool. Yeah, go for it. I need a volunteer. Okay. Do you have a tab with the API documentation in it as well? Or do you have a browser window? Cool.
Yeah.
Would it be possible for you to put it onto the screen just so we can bounce back and forth? I can share my screen too. We can try to play that game, but it might just be easier if it's on one screen. Yeah, cool. Okay. I
Down, but
think you want to go further down.
further down.
Yep. What I did to find it in the first place is I hit Command F and just searched for create.
Man, that's
Yeah. It's probably going to be pretty much at the very bottom of the page, I would imagine. It was near the very bottom of that list.
Just want to point out that if you show Terry's account token in there, it's recording, so we should probably delete it and make a new one after.
Yeah, good call. Yeah, if you share your screen and the token's on your screen, you should delete your token afterwards. Terry, if you go all the way to the bottom of your screen, just scroll all the way to the bottom, I think you'll basically be there. Yeah, or do that.
I thought it would be easier to just do it like that.
Yeah, the thing is when you collapse it, it changes how the scroll works. And
I don't get it, like why it does that.
Just go all the way to the bottom of the page and then go up and then you'll find it. It's probably like the second or third one from the bottom.
Oh, yep, I think that's one.
Yep, cool. Okay. So scroll on a little bit. I want to get to the place where there's the curl and the little it says like get and then the path. So keep on going down. Yeah, there we go. Okay. So it says post user repos. So what are some things here? We've got a method, post, looks like you've got that. And then the path looks to be, it's a way I can scribble on your screen. How do I do that? I don't know if I can figure it out. So whatever. The path looks like it's /user/repos. Take a look at what you have in curl or in Postman. So it looks like you have
highlight marker in the bottom left.
Say that again.
It should be the little highlight, the little pencil marker in the bottom left of your screen.
Oh, okay. Zoom changed their interface recently, and now I don't know where anything is anymore. So right there, compare that to right here.
I think it's repos, right?
Give it a shot. This is just going to be a lot of trial and error. Okay, so that didn't seem to work. Here's something I do want to point out that might be a clue. So you're assuming your username goes here. It looks like from this here, the curl down below, that they have the literal word user there. Okay, so here's something different happened, and different is really good in situations like this. So before you're getting a 404, now you're getting a 422, and this looks like you're getting further along. It's like giving you an error about creating the repository. So error, it says message name already exists on this account. So it's talking about name. Looks like that's the name. On the right here, can you scroll up a little bit? There was a section where it broke down what all the body fields meant, and there was one that mentioned name. Yeah, right there. The name of the repository. Okay, so what this means, it looks like, is this name field is going to be the resulting name of the repository in GitHub. It looks like this error says the name you specified already exists on your account. Maybe it's because you already have a repository called your username.
Yeah.
So it might be worth try putting something else in that name box. Something that you're sure you don't have a repository called that. like test. Okay, yeah, that works. Try making the request again now. Okay, so what do you see there in that response? Yeah, you got a 201, so that's good.
I see a name and then the full name.
Yeah. So when I see this big object and the 201 together, that to me pretty heavily implies that this was successful. So do this. Go to your GitHub and see if there's a repository called Nintendo in your GitHub.
Ah,
There we go. Pretty cool, huh?
yeah, it is. Wow. Okay. So, um, so like anytime I get like 422 or something like that, it's just meaning what exactly? I'm trying to understand.
Well, so remember how I said that there's a bunch of different codes that start with 4 that all kind of mean different things? 422 is one of those codes where it usually tends to mean that there's some sort of, well, it stands for 422 unprocessable entity. It usually means that there's some sort of like validation error that you have that's related to some sort of entity that your code affects, like some sort of resource your code affects, or your request affects, excuse me. But here's the thing, it's a 4, starts with a 4, and how different API providers utilize the response codes, it just kind of tends to be inconsistent. So some of them are very clear, like 404 means something that's very well understood. 401 means something that's well understood. 403. But there are some of these other ones where they kind of get used subjectively, and 422 is one of those. So I would say if it's not one of the 400 ones you've talked about, or if you look up that code and you can't find a clear explanation of it online, just treat it as a generic 400 and look for an error in the response body. Cool. Okay. Has anybody else been able to create a GitHub repository with Postman?
I have all good. I had it ready. Except I copied and pasted what was in the curl demonstration, and there was like, I think you submitted Terry's with name, description, and homepage fields, but since I copied it from curl, I had private to the false for Json was changing the repo to private. Uh, and then what was the other one? It was is template, and I didn't know what
Oh,
that did,
cool.
so I was holding off. But
Yeah.
I'm all good. I checked.
Yeah, I mean, like the cool thing here is you can make this request a few times. You can try the different parameters. You can read through the documentation, figure out what they all do. Um, there's some stuff like if you go through the GitHub repository creation form, there's some like parameters you can configure in there, and you can change all that stuff when you do it, create it via an API too. There's also some things that are in the settings, like you can sort of change like our pull request enabled for the repository. You can sort of turn those on and off when you create it via the API. So there's some extra stuff in there too, which is kind of cool. Sweet. Harry, I'm going to give you the reminder. You need to remove your token when we're done. It was shared, so it's considered expired and out there. So just like make sure you delete it. Cool. Anybody else have any questions on this? There's a bunch of other GitHub API examples. I won't really have time to go through them now, but I'd encourage you, if you're having difficulty with this, to give them a shot on your own. The endpoints, I believe, are all repository related, are all relatively straightforward to find the documentation. So if you look through that repository list, you should be able to find them all. They're all relatively simple CRUD-esque stuff. But anybody have any questions other than that? Okay.
Oh, actually, I have like one other question. So I was
Yeah.
doing the extra credit. I think it was week 11 text API stuff, and I managed to get like the Postman part down, but I'm having trouble where like the curl. Are we putting like netcat or are we like actually like writing like curl in the terminal?
Um, let's chat afterwards in Slack. I'm not sure exactly which exercise you're referring to, and I don't want to distract the whole class with it right now, but let's talk about it afterwards. Cool. Okay. I realize we're super over, and I'm really sorry, but I want to do one last thing, get everyone kicked off the New York Times assignment. So give me like 5 more minutes, and you all can go. I'm really sorry. Okay. So, share my screen here. So there are the other ones here, C and D, you can do on your own. Actually, there's also this too. Okay. So New York Times assignment. I think Max has sort of run you through roughly what it involves. I showed you an example. We talked about it a little bit. There's an assignment in the Canvas tool that's like explains how it works, has a little like blurb walking you through what needs to be done. So that's sort of like the official definition of it. However, there's something in there where at the very beginning it says you need to create your token and it walks you through how to do it. I would like to do it all with you right now on the class just so that everyone has it created. So I'm just gonna like do it on my screen, click through it. I just want you to follow along with me and generate your token. This token you're going to want to, just like with the GitHub one, keep somewhere safe. Don't share it publicly. So we're probably not going to do screen share for this one. What I'm going to generate here, I'm going to generate it. I'm going to delete it right afterwards. So like it doesn't matter for me, but just like keep in mind. Yeah, go ahead.
What if I tried doing this like last night and I already like generated like the the apps through the
Okay, cool. If you've already done it, then you get to basically just relax for the next 5 minutes.
Okay.
Okay. So this link here, the link I put in the chat, and also it's on the slide here. If you click on this, this will bring you to the New York Times Getting Started documentation page. So this is generally what you're going to have to go through here. The reason why I want to walk through it together is because the New York Times API documentation is a little bit shifty. It's not put together the best. And the reason why we're using it is partially because I want to expose you to some documentation that's like maybe not as high quality as GitHub's. It's not that it's bad, it's just not as good. So the first thing you're going to need to do is you're going to need to create an account. So this is like a New York Times developer specific account. So if you click on this in the link, this create account thing, fill that out, create your account. I already have an account, so I'm just going to sign in. So I'm going to stop screen sharing for a second and log in. Cool. So once you've created your account, I'm just going to close this tab, go back into this. I just want to start from the same this page again. Once you create your account, you're going to want to go home. Wait, sign in. Okay, come on. Yeah, there we go. See what I mean? It's like a little weird. Like I sign in, sometimes it doesn't register I'm signed in. I've got to like click sign in a few times, kind of just like keep kicking it until it works. So once I've gotten that, I'm logged in, you should see in the upper right-hand corner your email address. And once you do that, you want to go to apps in this little menu. And then inside of here, you're going to see a list of all your apps. Think of an app as being one-to-one with a token in the New York Times system. Within here, you're going to click New App, and you're going to create a new app. So you can, just like this is a lot like the GitHub personal access token thing, you can call it whatever you want. Careers in Code Cohort 6. The most important thing here, do I not have it in here? I swear I put it somewhere. Okay, whatever. I'll just say it now. The most important thing when you create this new app, you need to make sure Books API, this line here, is enabled. If you don't enable this, the request you're going to need to make for the New York Times exercise won't work. So this is sort of like giving your token permission to make that API request. So put in some sort of name, make sure you enable the Books API here. And then once you do that, click Save. This value right here, this is your API token under key. So you can click this to copy it to your clipboard if you want. That's what you're going to use when you make a request with the New York Times API.
Sorry, which one is it that we
Yep.
enable?
It's the Books API. Let me go back over to the form and I can show it again. Yeah, here we go. So it's, you want the Books API, this one right here. Third one down from the top, or yeah, third one from the top. So enable that and then put whatever name you want up here. Come on. Okay. Once you've created that, keep that token around. So I guess an important difference between New York Times and GitHub is they don't hide your token from you. So if you log back into New York Times and you go into the apps thing, you can find your app and get your token again. So still probably should like copy it, keep it around somewhere on your computer, but know that if you lose it, you can get access to it again. And also worst case, you can just make a new app like we just did. You can always watch the video again here and sort of see exactly how I clicked through it, or just reach out in Slack and I can help you with it. Also, this is, again, in the Canvas thing, but I've linked here to the particular documentation page within the New York Times API. That's the endpoint you're going to want to use. So what this endpoint does is it gives you the top 5 books for all the different bestseller lists that the New York Times has on a specific date. So the way New York Times works, I don't know if any of you know this, but like they have a bunch of different book lists, all of different categories, and then they have like a ranked list of books under each one. So this endpoint will give you data for all of those different book lists for a specific date. So every day they sort of have like a different list. Most of the time the books just transfer. Like today we might have like a top set of top 5 books, and yesterday we might have the same top 5, and the day before maybe there's top 5, but like one of them is different. So they slowly change throughout time. Like really the point here is just like this is data that you can render that will, when you render it, give you something that looks kind of like this. So here's one of the book lists. Here's the books inside of it, and so on and so forth. This is really fancy. You don't have to get this fancy if you don't want to. The minimum thing I'd like you to do as part of this, just like we did yesterday in class, make the request to this with fetch in an HTML page, get the data back from the API, and log it out to the JavaScript console. And if you can, take that JSON data and just dump it into the web page. So ideally, I would like to have it so that when you go to the page, you see the data you get back from the API in the page. You don't have to look in the console. That's the minimum. If you want to get fancy, parse that JSON, play around with it, make whatever crazy thing you want. That's all above and beyond. If you do it, it would be amazing. I'd love to see it. But minimum is just you need to make a request to this endpoint in a HTML page with fetch and take the resulting data and put it onto the HTML page. This is all in the Canvas thing. I walked through it. I just want to say it all in class just so you all hear it and it's all recorded. But that's kind of the goal. Okay, any questions on that? Cool. I'm going to give you all a bit of a warning in that the New York Times API documentation is, you're going to have some fun with it. And when I say fun, I mean like a challenge. You're gonna be like hitting your head against the wall. This is like part of why I'm giving you this is because I want to give you something that's like kind of more realistic. That's like a good example of the stuff you might actually encounter. The one hint I'm going to give you, just because this tends to help some folks, is in this API documentation, there's a bunch of information, but something that's worth noticing is there's a feature in here where you can actually try out the API. So you can like put data in here and you can click execute, and the web page will make a request to the API and will sort of like show you the results. So you can like try out the request in the web page. This is a pretty common thing you'll see in some API development tools, like in documentation. You'll see like a way you can try it out. But the hint I'm going to give you is if you can't figure out through trial and error what you need to do to make this API request work, consider trying to use the tool in the web page to make the request and looking in the network pane in Chrome DevTools and seeing the request it makes behind the scenes. Because what the page is doing is, in order to actually test out an API endpoint, it's actually making a real HTTP request. So if you can't figure it out, get that tester thing to work, and then inspect the page within DevTools and make it and see what it does. And if you copy everything from that Chrome DevTools into Postman and click send, you should be able to duplicate the request it's making and have a request that works. So that's my one hint to you. I think unless anyone has any questions, I think we're done for today then.
Is this your last class with us, or you got us for another week?
This is my last networking related class. Max has roped me in to do at least one day in, I think, August on TypeScript, and there might be one or two other days that I signed up for that I forgot about. So I'm gonna have to look and see if I did that. But this is the last networking day.
Alrighty. So you're not with us on Monday then?
Correct. Max should be back.
Alrighty. Well, thanks for instructing us.
Yeah, you folks have been great to show the ropes on this stuff, and this has been I think one of the better like cohorts for like I feel like people are like generally getting this stuff, which is exciting. I mean, I don't know, I could just be completely misreading the room, but like normally it in my experience, it normally is a little rougher than it has been this time around. So
Max mentioned a few weeks ago that we were one of the more technically advanced cohorts.
yeah. I don't like I haven't had to, I often have to like hit things a few times. I felt like I've had to do that a bit less for this group. So take that as it is. Cool. Well, I guess if I don't see you folks around, I guess I'll either see you next time I'm teaching, or one of these days. Like I'm up in Syracuse every couple months, and I try to make my trips align with OpenHack. Just I mean, all the people up there, and I need to catch up. So if you come to OpenHack enough, you'll eventually run into me at one of them.
All right.
Cool. Great. Well, have a good evening, folks. Have a good weekend. And I don't know if I should schedule an office hours. I did that last week. No one came. If folks want it, I can set something up. But I guess
Yeah.
let's chat about it in Slack and figure it out.
Yeah, I'm gonna say because I'm not a morning person. So if anything, if it's like around like either like 12 or like 1 in the afternoon, I'll definitely like attend the office hours.
Okay. I'll post a thing in Slack. We'll figure it out there.
Okay.
Cool. Okay. Have a good evening, folks. Have a good weekend.
As well.
Thank you.
Bye.